Welcome to this webinar, Optimize Your MPD Operation. Together with me I have Ingvild Bar-Aas from Halliburton, and it's myself, Morten Svendsen from eDrilling, that is running this webinar. In the application you are using, you can ask questions. So if you have any questions, feel free to ask the questions and we will try to answer them in the end of the webinar. So in this webinar we will have a look at the common drivers for using managed pressure drilling, and we will look at the life cycle drilling simulations in the managed pressure drilling operations. We will look at the use of the hydraulic model in the planning phase. We will look at the Halliburton MPD system and how it works. And we will look at the use of the hydraulic model offshore. So Ingvild, over to you.
Okay, I'll talk a bit about the common drivers for using the managed pressure drilling technique. This can be used to solve drilling related problems, like for instance lost circulation. This can come when you've got depleted reservoirs, abnormally pressured formations and also unstable formations. We also see that MPD is used in reservoirs where you have a tight margin between the pore pressure and the fracture pressure. Using MPD you get increased safety. You have an early kick loss detection system which improves the well control. The benefits of using MPD is that you've got good pressure control in a closed loop system, and you're also able to change the downhole pressure quickly without making any changes to the mud system. You don't need to weigh up or weigh down.
So, over to the life cycle drilling simulations in the MPD operations. And as many of you already have heard, eDrilling main concept is the life cycle drilling simulations. And that is also adaptable to MPD operations. And Ingvild will talk a bit about how they utilize the well planner in the onshore simulations, but also the use of the well balance in the real-time operations. But we also support training in managed pressure drilling in the WellSim Hydro Simulator and also in the WellSim Interact. So I think we just go further on to the next slide, and we will have a go through the different parts there in the slides coming.
Okay, when we start planning the MPD operation together with the customer, we sit down and discuss what the drilling window is, what the challenges of the well that's going to be drilled are, and then we look at the boundaries, what would be the maximum pressure that they expect to see, and also the minimum. And based on this we decide what would be the optimum mud weight, and also rheologies to use to achieve the goals for the well. We look into where the pressure should be held constant. Should this be at bottom at all times? Is it the casing shoe that's the weak link and we should hold the pressure constant there, or is there a zone in between, for instance the top reservoir? So then during the planning phase we also look at the other operations. Often we see that drilling the well isn't the main challenge. It's either the cementing or the displacement. This model that we use, the well balance that we use for the planning tool, can handle up to 20 different fluids. That can be different fluids, different weights, different rheologies, which is very beneficial, especially when simulating the cementing, which can have at least 4, 5, 6 different fluids with the cement and the spacer, in addition to obviously the displacement fluids. So then we work together very closely together with the mud supplier and also the cementing company to find the optimum both rheologies and weights of the spacer and cement and displacement fluids to avoid fracking the formation while during the cement operation. Yeah. In addition, we go through the
we just got a question, and that's quite interesting. Is the y-axis time or depth in these slides?
on this slide, this is time, but you can also set the simulation so that you have the axis as both volume, time, or depth.
Yeah. Okay. Yeah.
We also simulate the tripping, which we then look at. We can look at tripping speed. You've got pumping and pulling, which we can do, and also displacement in steps. The interface that we use for the simulations is also the exact same that we use during the operations.
So just a bit about the training part of it, the training part of the well life cycle drilling simulations. As some of you already know, we have some different products in the training part or in the WellSim family. And if you look at I picked two products here. You have the WellSim Hydro, which is a big team training drilling simulator where you have cyber chairs, virtual drill floor, and you have the WellSim Real Well. And if you look at the MPD capabilities, this system has its own generic MPD control system, but we also have an interface to the Halliburton MPD system, which we developed together with Statoil a couple of years ago, which we have been using a lot in the training on both the Gullfaks and the Kvitebjørn field. But we also have made interfaces to MI Swaco and Motherford MPD systems as well. And we have also worked together with Statoil actually to build a dual gradient drilling control system into the simulators, which they have utilized for training on the Troll field and also for the Gulf of Mexico when preparing for their dual gradient operations. And the kind of the benefit of using the WellSim Hydro or the simulator is that you actually build your real well in the simulator. So you bring in your MPD provider like Halliburton, and they train with their control system in our simulator on the real well with the real crew. So they were able to be training together with the crew they are doing the operation with, but they are able to train all people on the well and also the technology they are using. So we have seen a lot of benefit from doing that to prepare for the operation. The next you see there is the WellSim Interact, which is an engineering or engineer-focused simulator where we don't have the drill floor or you don't have the cyber chairs, but the focus is on the downhole, what's happening in the well. And there we have the generic MPD control system, but we are looking to kind of interfacing the other ones as well. This simulator is not kind of built for doing team training, but it's built to do engineering, but also training individuals on a well and also in an MPD operation to kind of prepare, for example, new engineers on the new technology and doing the job. So if you look at the features of this WellSim family products, you see there is a lot of kind of high pressure, high temperature, extended reach drilling. We do deep water fingerprinting, advanced well control, dual gradient drilling, coil tubing drilling, and tripping, stripping, and so on. But the kind of the benefits about using this kind of simulator in training, and if you look at the MPD as well, it's very easy to configure your well or the real well that you're actually going to drill offshore. We also configure the real choke with the correct dimensions and the CV curve and so on, so it should respond as on the rig. And we also have that open interface to other MPD control systems. And if you put on top of that again, we also have the downhole 3D visualization of the well. Yeah, that was quite quick, but go to the next. Yeah, we have a question. But we'll take the questions afterwards. So, over to Halliburton's system again.
Yeah, this is a simplified overview of the equipment layout that you'll get offshore, where you've got the here you've got the rig stack. Then we add on the equipment that's in red with a flow spool where the flow comes out. You've got the RCD. There's a MPD choke, dual choke. There's a flow meter skid, a back pressure pump that you use to get flow through the chokes at all time. And that can also be changed out with a rig pump diverter, which uses then the flow from the standpipe instead of a back pressure pump. So the automated choke skid, it's got two fully redundant chokes, which is designed obviously to handle drilling cuttings and mud. This is an automatic skid, which is got lots of built-in features. If there's a plugging, the system detects it, and the chokes are swapped automatically. We let the driller know that the system has detected a plugging. They pull off bottom, hold steady parameters while the chokes swap, and then we continue. If we lose communication between the control system and the choke will then maintain the last value it was given, and then you can operate the choke then locally from the panel if that's needed. The hydraulic valves that are the first barriers can be operated both locally or remotely. We've got a flow meter skid. As you take the flow out lower on the stack than you would normally do conventionally, you also then bypass the rigs that normally has a flow paddle or similar. We add in a Coriolis meter, which has got a lot more accurate than the rig's conventional system. We use this flow to compare it with the flow in signal. So here you've got the flow in blue, and then here you can see that already here there's about 40 liters difference from the flow in, and then you see that there's a higher deviance. This is 100 liters deviance between the flow in and flow out. Then we adjust the pressure on the model, and then we see that the flow in and flow out are back on target, and we've stopped losing. The Halliburton GeoBalance system has been designed to maintain plus minus 2.5 bar for all normal drilling activities. These activities include drilling, surge swab, tripping, displacement and connections. In addition, we've also been running the system with constant bottomhole pressure for casing and liner running, and also cementing. Together with the customer, we look at the objectives of the well and what are the main challenges, and based on that we decide what the window that is acceptable. Generally that's set at around plus minus 5 bar, and that's got to do with the tighter the margin you decide, the longer the tripping times are, and also the tuning of the whole system will take a bit longer time. Everything is done automatically, which makes it predictable. It isn't dependent on a good choke operator or a good driller that has a good communication then between. Everything is done the same way, independently of who's sitting behind the controls.
Yes, and then a bit about the well balance, which is actually the hydraulic model that Halliburton is using in their system. And this is a dynamic flow model that we use to provide real-time set points to the MPD control system based on the dynamic real-time simulations. So the model actually gives a pressure set point for their MPD choke in real time during the operation. And that is calibrated against the verified downhole measurements. We do drag and drop configuration of procedures to the simulated. It takes account of search swab effects. The back pressure pump is included in the modeling. And we also have the cross-application configuration that enables that you can transfer the configuration from the planning tool over to the real-time system without doing alterations. And the next step is also that we have what we call the simulation states, which is the if you are running a real-time operation and you can take the state from the model right now and take that over to the planning tool or the training simulator to continue doing the simulation to see if you are into a problem or something, you can see if you can solve it by what you think is the correct solution. And in short, so we have implemented the real-time dynamic hydraulic model into the MPD control system, where we are taking input from the rig operation to continuously update ECD and temperature profile in the well. And as Ingvild mentioned earlier, you decide if you want to keep a certain pressure at the bottom hole or at the casing shoe or anywhere else in the well. And the model back calculates all the time what pressure you need to keep your choke at. So yeah.
Okay, so a little bit about how the system works. The rig pumps and the back pressure pumps have been pre-set up to follow a predefined ramp up and a ramp down sequence. So when the rig pumps ramp down, the back pressure pump starts to ramp up, and then this is the flow through the choke at all times. When the rig pumps are down, the connection is performed as normal. The hydraulic model then disables the topside effects during the connection so that these are not taken into account. The model gives the choke a new set point every second, and this set point will then ensure that the pressure is kept constant at all times. This is a graph from an operation that we've had showing 3 connections. You can see in dark blue here, which is the desired bottom hole pressure, and then you've got this which is the modelled bottom hole pressure. This peak here is 2 bar. These dark green going down here is when the downlink is performed during drilling. The red here is the back pressure pump going up and down. See, we've got a question about the PWD. What we see and what we discuss normally with the customer is that during drilling we use the PWD signal to verify that the model is calculating correctly. We use it during the tuning to ensure that the model gives us the correct parameters as we go. Then during drilling, if we see that the PWD fails at the beginning of the section, the normal procedure would then be to pull out and change. If we see that we're almost at TD and throughout the section the model has proved to be quite accurate towards what the PWD signal shows as well, we continue drilling to TD and then pull out. So we would not change the PWD if we're getting close to the bottom. Some more operational examples. Some customers would like to see what their window is during the drilling to ensure that the pore pressure is what they think it is, what the prognose is. And also at the end of the section, some would like to do a dynamic FIT to ensure that we have enough window to do the displacement as we've planned it. So this window is what the window looks like for the operator. They would then increase the set point You see the set point increases, the PWD value follows. And then we would monitor the trends closely between the flow in and flow out. And the same for the dynamic drawdown. You would like to verify the prognosed pore pressure or verify that a zone is impermeable. Here the pressure is reduced by 2 points for 10 minutes. You then increase the pressure again, hold it, circulate bottoms up, ensure that there isn't any variance between the flow in and flow out. Then here it's reduced by 3 points, and then back it up again before you then continue drilling. Halliburton also has a data validation system built in as everything comes in automatically, both all the data from the rig, operator values. It's important that all of these things are closely monitored at all times to ensure that the system responds accordingly. Without this data validation system, we could end up in a situation where, for instance, the flow in reading from the rig would freeze. What would happen then is that if the rig then would change either increase or decrease their flow, the choke pressure would be continuing calculating what it was, and then you would have the wrong bottom hole pressure, which in worst case could lead to either a loss or an influx situation. So every data point that comes in, either it's operator read, or it comes in through data communication, or it is the sensors that we have. We have several sensors that are out in the field. All of those are verified, ensure that the data are correct. They're not a huge deviance from the previous value, and if they are, you would get a warning immediately. Either where the system would not allow you to be in automatic mode anymore, or where it just gives you a warning to say that, hey, this value is getting out of range. You need to ensure that the sensors are working correctly, still verified towards the others. Yeah, so all in all, using MPD gives you a flexible system. You can easily and very quickly either increase or decrease the bottom hole pressure. In a conventional system, you would have to weigh up, which would take a long time. You can use the system for dynamic FITs, dynamic pore pressure tests. The system, as it's automatic, it's also accurate and it's predictable. We use the system and the hydraulic model, the same tool for planning, and also during drilling, displacement, liner running, and we've also done cementing successfully for various sizes section. We use the hydraulic model for the planning phase and in the simulator trainings, simulations both onshore, offshore, and also during the real-time operations.
Okay, thank you. We have got some more questions, so we have some time, so we'll try to answer them as good as we can. So, can the hydraulic model perform simulations for multi-phase fluids like foam in the MPD operations? That's a good question. The model is basically a multi-phase model. But when it comes to foam, we haven't been doing that much simulations on that, and very often when we do, we have done a lot of cementing with foam cement. But what we often do then is that we simulate that the foam is stable and not kind of changing too much. And that is a thing that we have been looking into about using nitrogen in the model. And that is something that we are working at the moment, but we haven't used that directly in any operations. So does the eDrilling provide all the equipment necessary for building an MPD control system, or it's just the software interface? So eDrilling is a company that works with simulations and modeling, and we don't do control systems. So when Halliburton is using the well balance in their control system, we give them the model and the interface and the infrastructure for the model to be running, and we interface the control system, and we also get real-time data from the rig. So we support the normal communication protocols, and we try to embed us as tight into the control system as possible. But we don't do control systems ourselves. Have you used the eDrilling in customer interaction training for PMCD? And the answer is yes. We have been doing PMCD training courses together with a large oil company for training, preparing for PMCD operation. So we have experience with that as well, and the model and also the simulator is supporting that. And there's a question about the PWD again, and that Ingvild has already answered. What is the status of Halliburton's deep water below tension ring RCD? Is it already in the market?
I'm not sure, to be honest. What you can do there is you can send me an email, and then I can look into it and get back to you.
Yeah, you get the email to him.
Yeah, the email is it. Yeah.
Yeah. Next question: does your model use PVT relationships for fluids? Yes, we do. In our model, we have incorporated some other known models like standings correlations and so on, but we prefer to use PVT data for the fluids. And we can take the PVT data for the entire fluid as one, or we can take the parts of it. So if you have a oil-based fluid with an oil part and a water part, we can have a PVT table for each of them. And we actually prefer using that. Does well balance have a kick detection module? That's a good question. We don't have a kick detection module directly, but using it in an MPD system, I think Ingvild can answer that a bit better about kick detection.
Yeah, we have a kick detection system, but mainly uses flow in and flow out, that you compare these two values to see there. We also have a more sophisticated kick detection system, which also looks into other parameters during the operation. That's something that's built into our system, also based on the modeled parameters and what we expect to see during the operation.
And also, by using a model like the well balance, you actually are modeling what kind of flow out you should have as well. So if you have a good Coriolis meter, it's very easy to compare it as well, because the model takes account all the dynamic effects like temperature and oil movement. And also, like the next question here, does the model take into account cuttings? And yes, the model, as you are drilling, the model takes account of cuttings. And it also kind of builds up a cuttings profile, so you can actually have a good visualization of where your cuttings should be. And that is also, if you go back to what I talked about, taking a state from the well, then if you take a state, then all your cuttings concentration is also following the state, so you can have it with you. Can your model predict the total cuttings concentration in the wellbore? Yes, the model is modeling the cuttings, but if you look into the details of the what we are modeling, we are modeling the cuttings concentration distribution along the wellbore, and we are also modeling the cuttings transport ratio, which we call it, and how good it is to transport cuttings at any point in the well. The model doesn't do simulations on bedding, so that is kind of a weakness. But as long as you kind of compare the cuttings concentration with the cuttings transport ratio, you have a very good idea of how your cuttings is affecting the well. Okay, that was the last question. I have added the presentation as a handout, so you can download it. And feel free to send Ingvild or me any questions if you have any, and we will try to answer you as good as we can. So, thank you all for joining us, and yeah, have a good day. Bye.